Here we're asked to graph a piecewise defined function, but the purpose of this video is just to show you how to enter the answer into MOER. For example, I'm going to assume you know the graph of this piecewise defined function would look like the graph over here on the right. So notice that part of the graph is a horizontal line whose equation is y equals -2, starting at the point -1, -2, and is supposed to go to the left forever. Even though the graph is infinite to the left, it does have a definite endpoint at -1, -2. So choosing my icons here, I need a line segment that starts at a definite point but goes forever in the other direction. That would be this icon. I'm going to click where the horizontal line ends, the point -1, -2, click my mouse, let go. Then I'm just going to move my mouse so that the graph goes horizontal, choosing a second point on that horizontal line and clicking my mouse once again. Because I chose this icon, I'm communicating that this graph goes to the left forever. The next part of the graph would just be this line segment that starts at -1, -2 and goes up to 1, 0 here. So I'm going to select the icon that is a line segment and does not go to infinity in either direction. After clicking that icon, I will click at the point -1, -2, move my mouse up to the end point 1, 0, click again, and let go. Eventually I need to put some closed and open dots in the graph. You can either do them now or later. I'm going to wait till the end. Finally, the third piece of the piecewise defined function is the horizontal line y equals -1 and starts at an x value of 1 but not including 1. So I need to, once again, pick the icon that represents a line that goes infinitely far in one direction but has a definite endpoint. In geometry, I believe this would be called a ray. So I'm going to click this icon here, which reminds me of a ray that starts at some endpoint. In this case, we're supposed to start at 1, -1. And I move my mouse to pick a second point on the line y equals -1, and it does go to the right forever. I had to click my mouse a second time to choose a second point on that horizontal line, y equals -1. Now if you read the directions, it says, note, be sure to include closed or open dots, but only at breaks in the graph. So you will get this question marked wrong if you plot a point at -1, -2, because there's no break in the graph right there, and it said only put the dots where there's a break. So there's only a break in my graph at x equals 1, and that'll require two dots, one open and one closed, to communicate which one actually is the point on the graph. So I'm going to choose the closed dot and put it at 1, 0 to indicate when someone plugs in x equals 1, the y value would be 0. And then I'm going to click an open dot here to let them know that that point does not count on the graph, that when plugging in 1, you only get one y value. Not the one down here at -1, but you'd get y equals 0 if you were to plug in x equals 1. Now that this is all done, I can submit my answer and make sure I get full credit.